Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to talk about this problem right here, the addition of chlorine and water to a pi bond. Before we get into it, please go ahead and slap that like button, leave a comment down below. Tell me what you think so far about this video series. Also, subscribe to my channel. It really is helpful when people subscribe to YouTube channels. It tells YouTube the creators are doing a good job. Let's get into it. So now we have a pi bond. So let's just see here. Pi bonds are pretty reactive, and so is chlorine. So let's start there, right? So we have and some chlorine. It's kind of a weird mechanism, but this is what happens. We have a bond forming step right here to attack the chlorine. We have a lone pair attacking the other side of the double bond because it's a bond forming step, and we have the electrons leaving. So it's a little bit weird. Maybe you haven't seen something like this before, but this is how a chlorination of a double bond works. This is the first step in chlorination. And there we have the chlorocation. Now, at this point, the chloride that was liberated, remember we liberated a chloride, could attack this position here. It could. But now we also have the nucleophile water added into this reaction. So water, in fact, is what does the next step, because water is more nucleophilic than chloride. Chloride is, and water especially, chloride is very stable. How do we know that? Well, it's the conjugate base of a strong acid, hydrochloric acid. So chloride, given other opportunities, will generally not react as a nucleophile. It can, but generally it doesn't. There you go. And that's why this methyl group is going down. The OH is coming up like this. Now it's protonated alcohol. We'll fix that in a moment. All right. And now more water will come over. Say, how do you do? Oops, let me change that color. Deprotonate the alcohol, giving you the product. Now, I only draw one enantiomer here. You have to remember this will be both enantiomers. You'll get a racemic mixture of products. Plus the enantiomer. All right, and that's how this mechanism works. Now, the reason why the alcohol forms and not the dichloride is, again, because water is more nucleophilic than chloride, and that should make perfect sense to you because you all know that chloride is very stable in water because you know that hydrochloric acid is a strong acid, which means chloride must not be very reactive in water. So therefore, water is a nucleophile in this reaction. That's why you form the alcohol. All right, guys, if you found that video helpful, please go ahead and slap that like button, leave a comment down below, subscribe to my YouTube channel. It is always very helpful when you do that. And with all that, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.